Hi everyone. This example is an example of the work equation, but with dot products because we have unit vector notation here. So we have an ice block floating in a river is pushed through displacement d of 15 meters I hat. So our d is 15 meters I hat minus 12 meters j hat. And then along a straight embankment by rushing water, which exerts a force F of 210 newtons I hat minus 150 newtons J hat. So our F is 210 newtons I hat minus 150 newtons J hat. Then it says, how much work does the force do on the block during the displacement? So the key here is that work is a scalar quantity. And here we have the dot product. So work is equal to force dot displacement. So what this means here, when we're doing dot product, I hat dot I hat is equal to 1, and j hat dot j hat is also equal to 1, but I hat dot j hat is equal to 0. I said 1, but I wrote 0. So when you're multiplying the x's together, when you're multiplying the y's together, then you get something, because we know that work is at a maximum when our force is parallel to the displacement, right? We have two x values or two y values or two z values. However, when we're perpendicular, so an I hat and a j hat, then that is 0 work done because the cosine of 90 is 0. Okay, so this is why this dot product works like this. So all we do when we get numbers like this is we're going to multiply the I hats together and multiply the j hats together, and then all we do is add them together. That's it. All right, and it seems so silly and simple, but I'll explain when we're adding them together, okay? So all we're doing here is we're gonna multiply 15 by 210, and then we multiply negative 12 by negative 150. So our work done is going to be 15 times 210, which is 3,150, and that's joules. And then a negative 12 times a negative 150 is 1,800. So we get 1,800 joules for that y component. And now the deal here is that this is not unit vector notation now that we have, because work is a scalar, which means it is not a vector. It doesn't have a direction, all right? A positive or negative work just means we're either giving that system energy or we're taking away energy from the system. So here, all we do with these two numbers is we add them together. That's it. Okay, because it's a scalar, it's not a vector. You're not using Pythagorean theorem or anything like that, or unit vector notation, because again, work is not a vector, okay? So all I'm going to do is add them together, and we end up getting a work of 4,950 joules.